So for example 2, we have natural log of x squared. Okay, so what's the instantaneous rate of change x equals -1? Different wording, but it still means the derivative, right? It still means the slope of the tangent line. So step 1 is going to be the same. You can find the derivative of that. What rule would you use to find the derivative of natural log of x squared? Yeah, so derivative of ln of x is 1 over x, but you have an x squared inside, so you'll also use the chain rule. Okay, so basically, instead of 1 over x, it will be 1 over the x squared inside, right? Derivative of the outside, plug in the inside of that, and then times the derivative of the inside would be 2x. That's going to simplify. You have 2x over x squared. What will that become?
2 over x.
Yes, 2 over x. And since we're finding the instantaneous rate of change at x equals -1, we're just going to plug that into that formula.
-2.
Good. So 2 over -1, whoops. We'll plug in -1 in for that x value right there. And that should give you -2. Okay. So plug in -1, 2 divided by -1 gives you -2, which means the slope of the tangent line of natural log of x squared at x equals -1 is -2. Let's pull our graph up and see if we can confirm that. Natural log of x squared, but it looks like, kind of reminds me of like bird wings if you look from the side. It kind of curves in it the same way, but check it out. At -1, we have this orange line, and we can see the slope is about -2, down 2 over 1. So again, when you find the derivative of the point, you're finding the slope of the tangent line at that particular x value.